next talk, it's a pleasure to present Andreas Rossberg. He's going to showing us keeping the assembly in Wasm, running high-level languages on the low-level VMs. So, floor is yours.
Yeah, thank you very much. So when Stefan asked me to give this presentation, I was thinking like, oh yeah, interesting idea. And then a couple of days later, I thought like, oh God, what should I actually tell? So I should apologize in advance if for those of you who have seen my talk on Sunday, there will be some overlap with the slides here because I have to do some kind of similar scene setting here. So I hope that doesn't bore you too much. So WebAssembly is this like virtual machine that is running in lots of different environments, not just the web. That is more like a historic accident in that name. So we really have to support a wide diversity of ecosystems, right? Ranging from desktop to embedded. So one of the characteristics of WebAssembly is it's a low-level virtual machine. It's supposed to be language independent, so no specific language has no bias to any specific language. It also doesn't have any bias for a specific platform at all, so it's not a web thing. It can be embedded anywhere, and in reality there are more than a dozen implementations of WebAssembly engines already that you can pick from and embed in your program. And they have very different characteristics. And an important part of it is that its semantics is designed to be portable, right? Ultra-portable, deterministic, and there's a sandboxing model which also makes it attractive for many. And it's an open standard, so that anybody can work on. But I don't know how closely you follow the development of WebAssembly over time, but there has always been like this grand roadmap essentially underlying the development. So when we started out, it was clear the first kind of thing we have to achieve is having good support for low-level languages, right? That was our first line of customers. They were already compiling C++ applications to the web, for example, and we wanted them to support them and be able to deprecate like other legacy technologies like NECL, native client, and ASM.js, which were more hacky things. Since then, we have more or less worked on kind of stage 2, like better support for high-level languages, right? So, and I'm thrilled to say that very recently, many of these features we have worked on for years have kind of, we pushed them over the finishing line, so things like tail calls, garbage collection, exceptions, and stuff like that, many of which would be relevant to dynamic languages as well, I suppose. And then there has always been like this stage 3 thing as well in the back of our heads, but to be honest with you, nobody has really like given that any real thought yet. So most of my talk here will be rather like me speculating about what that could even be, right? Right, so to give you a bit of a picture of WebAssembly, so imagine you have an application, let's say a web browser, and you want it to run WebAssembly. So the way you do that is you use an existing engine and embed it, right? So it's kind of, you can use it as a library and you embed it in your program, you link it in somehow. And then we call the program that does that the embedder. Inside the engine, you have two main components. One is the actual runtime, which is mostly about memory management and stuff. And then there's the compiler, which goes from the Wasm bytecode to the respective native code of the platform you're running on. The embedder can, and that can actually be both a JIT or it can be an AOT compiler that is completely dependent on the setting you're running in, and the whole design of WebAssembly is such that you can make both of these choices. So this is kind of important for the context here as well. Right, so the embedder can talk to this engine through some embedder API. There's some standardized or semi-standardized ones, but they also usually have their own ones. And one of the obvious things it might want to do is ask it to instantiate a bunch of modules, right? So WebAssembly binaries come in the shape of modules, and you instantiate them, which means they will be passed through the compiler on your local machine and turn into native code, which is then placed inside the runtime, and more specifically the WebAssembly sandbox. So all the native code there will be in terms of modules that run inside this sandbox. And then the embedder can talk to these compiled modules through their imports and exports that they have declared initially. And that's the only way to talk to them as well. But that's just like one scenario, right? The web browser. So on the previous slide, you saw all these other environments we want to support. And another one might be embedded systems, for example. So what does that look like? The situation is a bit different here. You want to run on basically some chip, right, directly, more or less. So the setup will usually be a bit different. You actually want to do AOT compilation outside the system and then create the final code and load that onto your hardware. So part of your engine, if that is even the right term in that context, then lives outside the engine. And also, so the compiler in particular. And also you want the runtime probably be like as lean as you can possibly make it, right? So really just consists of the code ideally. So just to give you a bit of background of what the constraints are that we have to meet across these diverse landscapes. So I had this list of kind of defining features, and one was like low-level virtual machines. So what do I mean by that? There are various characteristics that you can assign to that property, but the basic idea I usually describe as being that Wasm is an abstraction of hardware, right? Unlike other like mainstream VMs, it does not abstract some language above you, like the JVM would be an AST for Java essentially. We try to basically be an AST for your CPU instruction set. And that means that all the languages that you can hopefully run on WebAssembly, the goal is that they're all like really equal citizens. We don't give any of these languages any particular privilege, right? That is very important to the design. So, and that is the way for us to support both like language and platform diversity in an equal manner. And as far as I'm concerned, that is the only way to do it. That's the only way to achieve this kind of neutrality. You have to be low level. Everything else will eventually like get you into some dead end or completely unmaintainable mess of semantic constructs. So we want to maintain this kind of property for WebAssembly. And that is probably why my talk might be a bit disappointing to some people in this room. But let me first concretize a little bit what that means. So yeah, WebAssembly is an ISA, so it's really just an instruction set like you would find on a CPU, but a virtual one. And the idea being that it really maps almost directly to hardware instructions. And you can predict what instructions it maps to if you know the hardware. In most cases anyway, there are some exceptions, but in general that's the idea. And that should give you a very transparent and explicit cost model, right? So really know what kind of code you're generating ultimately. And that is important if you're writing a complex compiler or runtime targeting this thing. You really want to know what's going on. You want to have predictable performance in the end, right? If there's a higher level abstraction in between, you often have the problem that you don't, like you have competing abstractions and competing optimizations and stuff, and you don't really know what you're doing. You already have this problem today with modern CPUs, right? They do a lot of fancy stuff under the hood, and sometimes optimizations are completely counterintuitive in their results. But yeah, you also don't want anything implicit like runtime type tests or anything like that. So that is important. Again, if you compare to the JVM, when you access a model, an object, you essentially have a runtime type test every time, right? This is not something we want to have on this level. Or that you would have to optimize away with complicated things like inline caches like a JVM would do in practice, or more complicated compilation patterns, JIT patterns. Yeah, so of course there also is no such thing as an object model, and in particular the whole VM is designed to not require GC. Even now that we have a GC extension that is completely optional, you don't have to use it, and if you don't use it, it doesn't cost you anything, right? Yeah, most optimizations is really the job of the compiler producing WebAssembly, like as if you were compiling for native code, right? We don't assume that the engine is doing anything particularly clever. So really, we are using JITs because you have to somehow translate the portable abstract bytecode to actual machine code, but that is really all it should be doing in an ideal world, right? It should not have anything clever in it. So the JIT is really just a way of translating the instruction set. But that's the ideal. Of course, there are some limits to it. So because we are operating in this like triangle or tetraeder of competing constraints and concerns, and you have to balance these somehow. And that means that we can't really be as low level as a CPU in reality. In particular, because we have to maintain safety, absolutely, right? That is not negotiable, we have to do that. And that means we have to rule out certain behaviors and we have to do certain checks. So my slogan for explaining this is usually, we want to be as low level as possible, but no lower. Meaning that it's not a free pass, right? We have to raise the abstraction level sometimes, but that is not a free pass. That doesn't mean you can do anything, right? We often get like requests, okay, why don't we add like, I don't know, vtables as a primitive to WebAssembly or other things, right? And then that would kind of like go against the spirit and bring you into this hell of like ever-blooming complexity ultimately and creating language bias. However, there are obviously counterexamples of where we had to raise the abstraction barrier, and I just want to mention a couple of them. So the first one, and I also mentioned that in my talk on Sunday already, is like functions. So CPUs don't know anything about functions, right? You just have code in memory, you jump back and forth between that. In WebAssembly, we have functions as a primitive notion, and there are various reasons for that, having to do with safety, security, so you don't want to expose the stack, but also performance, so that the engine, which knows the actual hardware, can pick the right calling conventions, the ones that are efficient on the hardware it's running on, and other reasons. But it's really just a mechanism to group code. It doesn't do anything more fancy than that. A function reference is still just a code pointer. I mentioned garbage collection, which we now provide, but again, that is much more low level than you might probably expect. So I talked about it like 2 days ago more extensively, but it's really, the idea is that you don't have objects or anything like that. You really just describe the data layout of data structures like you would generate them on native code and use them to tell the GC how to manage the memory. But it doesn't do anything else for you, right? It does just manage the memory. It doesn't do objects or anything like that for you. You still have to encode all that manually. Another thing we're working on right now is continuations, for example. That is not yet like close to being accepted, but again, this is kind of like an abstraction trying to be as low as possible over like the notion of a stack, essentially, right? So really, it's a way to model stack switching. So those are a couple of like higher level abstractions, if you want, that are in WebAssembly already. I'm going to list you a number of things that we don't want to put in there. That would be higher level abstractions that we don't think should be in there, or I at least think they should be in there. So higher level data types like strings. There has been long controversial discussion about making strings primitive in WebAssembly. Bad idea, because they're way too diverse. Things like big nums and other things you can think of. Obviously, an object system, I already said that. The dispatch mechanism, I also already mentioned that. All that you should have to implement yourself. Dynamic typing, obviously. Runtime types, not something, at least not in the way they occur in the source language level. They should not be primitive in a system like this, or let alone reflection, right? In general, like anything that is specific to a given language or family of languages or language paradigm should not be put into WebAssembly as a feature. You should have to implement it on top of WebAssembly. And anything that can be efficiently implemented on top of WebAssembly as well, even if it's kind of like universal. So garbage collection in a way is already kind of like the boundary to which we are willing to go, if you want, and some people would argue it's already too high. So the basic message is like you should really think of implementing a language on top of Wasm like you think about it on top of native, right? In an ideal world, anyway. Unfortunately, when it comes to like dynamic languages and type-challenged languages, then there are a number of limitations you will run into here. Because we have these constraints and this slightly higher levels of abstraction, when you want to make a dynamic language fast, you basically have to pull every dirty trick from the book, right? And more tricks that are not in any books. So I've worked on V8 for 8 years or something like that, and I still, even in retrospect, I find it mind-blowing what is going on in an engine like that, and also kind of disgusting. And many of these tricks you play there to make it fast just won't work. on something like WebAssembly, at least not as it is now. So for example, there's no way you can have unsafe code, right? VMs are full of unsafe code because they make all these global assumptions about invariants, and sometimes they get them wrong, but that's the way how you do it. We also have this strong module system in WebAssembly, and we should absolutely not break that encapsulation guarantee because the whole sandboxing mechanism depends on it. You don't have any access to registers directly. You don't have any access to the stack directly, right? All these things that VMs do where they need to pin registers or, I don't know, traverse the stack, do all sorts of weird things you can't really do directly. One thing that engines like JavaScript engines do is more advanced even in terms of stack stuff. They rewrite the stack, right? So when they have this thing where at runtime they optimize and de-optimize functions that are currently running, so who have stack frames on the stack, live stack frames. And that might completely, if you recompile a function to a different format, like you tier up, you tier down in your compiler pipeline, that might need a completely different stack frame layout. So the VM would dynamically rewrite the stack. It would even merge multiple stack frames when you have like inlining, or you stop having inlining in that process. So again, something that's completely out of scope for doing that in WebAssembly, right? And of course, self-modifying code. No way you're going to have that. This is something I would assume is a bit on the way out, but like traditionally engines are full of that, right? In particular, one popular technique that uses that, or at least traditionally uses that heavily, is inline caches, like they are used for JavaScript, but have been pioneered in the Smalltalk community. You can do them without self-modifying code, but then you pay for an extra indirection, right? But there are many reasons why you probably need to go that direction anyway, because security, control flow integrity, and all sorts of things coming our way more and more, that this is probably not gonna be sustainable using self-modifying code. And then ultimately JITting, right? How would you JIT in WebAssembly? And I should say that many of these things are kind of related to having access to code in some way or the other. And that is one place where WebAssembly really differs from real hardware, in the sense that real hardware is a von Neumann machine, right? So you have code as data somewhere in your memory. You can just play around with it if you want. That's not at all the case in WebAssembly. WebAssembly in that sense is really more like a Harvard machine where code is in a completely different space. You don't even have access to it at all. You can't see it, you can't do anything to it. And that definitely is a feature, not a bug, right? But it gets in the way of all these things. So what does that mean for a roadmap? Right, so I showed that. So in some stage we might want to have better support for dynamic languages anyway. So what do we mean by that? And it's a good question, and I want to be honest with you, I don't really know the answer. So the rest of my talk will just be me speculating over a bunch of things that I think are kind of at least necessary in some way or the other. But that is not a definite answer at all. And also there's no time frame here. I can't promise anything. There's nobody actively working on it because we haven't had much pressure or interest really from these communities to get involved. And I mean, as I said, it's an open process. So if you're a dynamic language implementer and you need some features, then you would have to step up, write proposals and stuff like that, right? That's how it works. We are not doing it for you unless there's somebody who needs it. So, but the general idea really just is that, yeah, we won't provide high-level language mechanisms. We want to provide at best implementation mechanisms, and low-level ones at that, right? So a bunch of examples I just have out of the top of my head, more or less, that I could think of that seem to be relevant, especially in the context of JITting. So the first is we probably need a way to do dynamic code instantiation. So in WebAssembly, code comes in modules, and modules are mostly like a static notion, right? You can dynamically instantiate or link a module, But right now, that is only possible through external APIs, right? So on the web, for example, the JavaScript API gives you a way to instantiate a new module, and then you can pass out its exports to other code you have already instantiated, and that way you can link them together. But that only happens in JavaScript, or similarly in other APIs like on the C level. There's no way to do that from inside Wasm. So if you wanted to implement a runtime that does all these things with dynamic code generation or specialization, then there's no way you can implement that in Wasm itself right now. So the first idea would be that we somehow have to lower this instantiation API into the language in some way, one way or the other. So I don't know who is particularly familiar with WebAssembly here, so this slide might be a bit technical for those who don't know WebAssembly, but just to roughly sketch the idea of what that could look like more concretely in WebAssembly. So the first thing would be that we would have to introduce, would have to allow modules to define local modules themselves. And we would have to introduce the notion of first-class reference to these various things that modules can define. So what you already have in WebAssembly is function references. So you can reference local functions. But to be able to link up modules from inside the language, you would also need to be able to reference globals and tables and all the other things that modules can define. So have like instructions for taking the address of, I don't know, a global or something like that, intuitively. And then you would need like kind of an instruction to instantiate one of these nested modules, for example. So it could look something like this. It takes as operands on the stack a list of imports, so references to some of these things it requires, and it gives you back a list of its exports. That would be the most direct way of providing this, right? And there's nothing in principle that prevents doing this. But, of course, if you want to get any benefit out of it, it kind of implies that the engine does compilation of this nested module at instantiation time. So only then you get the benefit of it being able to specialize any code for you get out of that. I have an example here, but I think in the interest of time, I might actually skip over that. It just tries to give you the general idea that you could have a local module whose role is to specialize some stub code or something, and by instantiating it, you specialize it to some specific descriptor value. I don't know. There's a lot of like VM speak here, which probably I don't have time to walk you through, unfortunately. So let's rather move on to the next kind of thing. So this is like a first step, right? This is like still, the code here is still sort of static. So I had this module, this nested module already defined, and I instantiated dynamically, but the code itself I can't really do dynamically. So basically, there's no way, another way to look at this is like engines have a JIT, but you don't have any way of using that for your own purpose. You can't really JIT code other than very indirectly through code that is already there, and then you're kind of depending on the compilation strategy of the engine. But runtimes like want to use JIT, sometimes anyway, so that would correspond to the ability to actually generate a module dynamically, not just instantiate one dynamically, but generate one dynamically, which is not currently possible, even with the extension I just showed you. So the idea there would be, again, to lower something we already have in the API, namely the compilation interface, into the language. So first of all, you would need some new notion of types that define the types of modules, so they're signatures if you want, so that you can form references to modules, right? You can reference these things, and then you would have like this one super meta instruction for creating a module. One way it could look is like this. So it takes a reference to some memory and a range in that memory and interprets that as bytecode that it's supposed to compile. And then it gives you back a reference to the module, and you can use a variation of the instruction I showed before to instantiate that thing. So the variation would be here that it actually takes a reference instead of a static module name. And these are mega complicated instructions, of course, and they embed the entire, they definitely require going into this model where the entire engine is inside the execution environment, right, where you can't do AOT anymore. So this is definitely not for all environments. Okay, again, example, variation of the previous one. Let me skip over that. And the last thing I have is that is a bit different direction. So the technique that languages use is sometimes called hidden classes. So that also comes from the Smalltalk community originally, where you kind of try to infer from the layout of an object. You identify that with a class that you generate on fly, some identity, which is kind of a descriptor. And you transition objects when you change their change, you transition their class to something else. So engines do that behind the scenes. In V8, these are called maps. I think in Firefox they're called shapes and so on, but they all have them somehow. And in the GC proposal for WebAssembly, of course, you also need to have descriptors internally somehow in the engines for the GC to use, right? But they are completely encapsulated. You can't piggyback on them as a runtime on top. So in particular, you cannot attach any additional data to these things. So it would be nice if you could do that and use these for your own purposes. So that would be possible by providing access to these descriptors somehow. So introduce a way of generating custom ones. So first of all, you somehow have a new form of type that describes the descriptor for some other type. So it's kind of like a meta thing if you want, and attaches a number of fields to it, for example, that you can pick. And then you can allocate these things, blah, blah, blah. And then you have variations of the allocation instructions for regular objects that take one of these as an argument explicitly instead of you doing the implicit thing and inserting an internal descriptor. So you don't really have to read all that, but the idea is, yeah, you can provide that explicitly. And you can extract that then in any place you need so that you can work with it and use its information. So this would give you a way to attach essentially static fields to an object, for example, right? Which is, again, something that engines do on a regular basis, engines for dynamic languages. Right, and you might think of more things you can do with that. So this, as I said, this is just me speculating. There's lots of open questions here. I'm not going to go through all of them, but one big one is if we do all that, how does this not become a huge reflection mechanism? Right? And maybe the even bigger one is it actually worth it at all? I mean, given Kevin's talk before, maybe you just don't want to do JITting. That might be an answer too. This is all too complicated, not worth it, and you should just be writing an interpreter if you insist on self-inflicted pain of using such a complicated language. Then that's what you have to do, perhaps. I don't know. That might be an answer. I'm not saying that is the answer. Okay, that's all I got. It's pretty much an open problem. It's a summary, and we don't really know how to solve it yet. But we would very much appreciate input from this community and actually investigate this, because right now we don't have anybody who's doing that, right?
Okay, thank you. Let's thank the speaker. So we have time for a couple of questions. We have one here.
I was just wondering, so I guess when you were talking about the JIT compilation and you called back to the slide where you have, in the embedded scenario, you have the AOT that's outside of the system.
Yeah.
Is it possible that there may come a time where there's sort of like a host profile or a better profile where you have kind of some embedders that only support a subset of the spec?
It's funny how this question around profiles keep coming up lately. Yeah, I have a proposal actually for introducing profiles into WebAssembly. There's a bit of controversy around that because some people just don't like the idea and think this furthers fragmentation of the language. I think it actually does the opposite, because that fragmentation already happens. It's just completely growing wild, and we should control it some way. But I would definitely think that for a mechanism like that, yes, you have to have a profile that excludes it somehow, so that embedded systems can work with a lean VM.
Okay, and this, you have a profile, or sorry, you have a proposal that's already
So it's
open,
yeah,
or?
it is, I don't know what stage it's at, but yeah, I mean, it's two parts. It's a proposal which is just like an editorial framework for doing this kind of thing, and that's already adopted for one of the features we have now voted in, which is relaxed SIMD. So relaxed SIMD has this very unfortunate property that it introduces implementation-dependent behavior. So we required to add a deterministic mode so that you don't lose the nice properties of WebAssembly over this. And that is defined in this framework. So basically the setup is the specification of the language specifies the whole language, and then you can mark individual constructs or rules as excluded in a certain profile, right? And this way you can have like subsets, well-defined subsets or intersections of subsets even for certain needs.
The proposal is stage 1.
Yeah, technically it's stage 1. I think we had an in-person meeting 2 weeks ago where we essentially decided, because relaxed SIMD, which just got stage 4, depends on it, we kind of implicitly accept it. Yeah.
One quick question. So it's more like a clarification. You mentioned that you have support for GC, but if I understood correctly, you say it's not required. So then
Yes.
why is it there? In which cases are required?
Well, you can use it as a producer, so a compiler targeting Wasm or runtime, right? But you're not required. Like if you don't use it, then there's nothing in the rest of the language or the instructions that depends on you using it. So it's completely isolated from the rest of the language, and there are no cross dependencies with other features. That was very important in the design.
Okay, we have one more question, and then we jump. Can I ask you for setting it up? Yes.
Hey, thanks for the talk. I guess somewhat naively, I assumed because WebAssembly's text format is, like S expression based, that it would be okay to operate on the WebAssembly text format itself for optimizations, but you suggested that that's just a bad idea. Could you add some color to that?
Oh, well, so the text format is a text format, right? Which means that engines don't understand that. Engines only understand the binary format. The text format is just a human-readable representation of that. So, yeah, I mean, you can hack on the text format, but that's not what you want to do inside a runtime, obviously.
Thanks. Good. Let's thank the speaker again.